is Algebra 2, Unit 5, Lesson 7, and today we're going to learn about imaginary numbers. And so far, all of the radicals that we have taken the square root of have been positive underneath the radical, unless they were an odd root number, like the cube root of -1 or the cube root of -8, something like that. So the cube root of a negative is going to be a negative, that's okay. But we talked about how if we have the square root of a negative number, that's not possible. At least we said not until later. Well, now is later. We're going to learn how to deal with a negative under an even numbered root today. So to introduce that, I want to show you a real simple quadratic equation to solve. And if we were to solve this, remember, the first thing we would have to do is get it equal to 0, which in this case it is. And now I could factor this to get the answers, but instead of factoring it, I'm going to show you a different method. Since there is no middle term here, it's not necessary really to factor this one. I can move the 2 to the other side, so I'll have 2x squared equals -2, and then if I divide by 2, I have x squared equals -1. And then we learned that when we were solving equations like this, if we want to get the x by itself, we can take the square root of both sides of that equation to get rid of the radical, because a radical will undo a square. A square root undoes a square exponent, or an exponent of 2. So over on this side, I would end up with just x. Now on this side, that causes a problem because we have a negative number underneath the radical. And so far, all we know with that is we have to put no solution. We don't know what it is. But years ago, I believe the mathematician that has been credited with this is Rene Descartes. He decided that, well, if we have a negative under the radical, let's just make up a whole new set of numbers. And if we decide that this number has a value, then from now on, whenever this shows up, we can replace that value with the number that we come up with. And what he came up with is we're going to let the square root of -1 equal I. And I represents an imaginary number. So the square root of -1 is going to be an imaginary number. Now, think back to when we talked about radicals. We had said that if you take the square root of a positive number, couldn't our answer be positive or negative? Because like -5 times -5 is positive 25. And 5 times 5 is positive 25. So technically, if we take the square root of 25, really we could get either positive or -5. And so here's our rule now that we're going to use anytime we have to, as a mathematician, anytime we put a square root into an equation in order to solve it, or any even root into an equation to solve it. Since we know that the square root of a number could be positive or negative, when we have a problem that we physically have to put the square root into the problem to solve it, from now on, we will always put a plus and a minus in front of what we get. Now, the square root of -1, remember, we have named it I. So the answer to this equation is x equals positive or negative I, or plus or minus I. This is an imaginary number. We'll talk more about what this means when we get into graphing. Now, we said in the last, or one of the last sections, that if we have an x squared term, that polynomial, whatever the degree of the polynomial is, tells us how many answers the polynomial should have. That is a reason for putting the plus minus in front. If we hadn't put the plus minus in front, it would appear that we only had one answer. But we know that since it's a square polynomial, it's a quadratic, we know there have to be 2 roots. And so this gives us both of those roots. So the rule is, when you're solving an equation, if you have to put a square root in the equation in order to solve it, then when you take the solution of that square root, you have to put a plus and a minus in front. Now, we won't do that anymore in this section, but it's going to come up soon in the next chapter, I believe. So we won't really deal with this yet. I'll revisit this again when we get there, but I just wanted to show you this to introduce to you where this imaginary number comes from. Okay, so remember, anytime you have a square root of a negative, there will be an I in your answer because the square root of -1 is I. Now, looking at some other examples. The square root of -9. When I do an example like that, the very first thing that I have to do is I have to take out the negative. If I don't take out the negative, then I can't answer the question, okay? So basically what that means is it's the same thing as -1 times 9. Hopefully you can agree, based on the math that you know, a 9 times -1 will give us a -9. And then, knowing what we know about radicals, we are allowed to separate that out, and it becomes the square root of -1 times the square root of 9. Then we can simplify this based on what we know. Well, we know that the square root of -1 is I. We also know that the square root of 9 is 3. So if we multiply those together, our answer for that will be 3I. The most common mistake that I see with square roots of negative numbers is students forget to take the I out first. You have to take the I out before you're allowed to do any operation on that imaginary number or that negative root number. So you have to take the I out before you do anything else. So that should be always your first thing that you're going to do when dealing with a negative root. Looking at this one, we're going to solve this one exactly the same that we did in the last couple of chapters, except before we simplify that, we have to separate it out. That's the same thing as the square root of -1 times the square root of 125x squared. Then we know the square root of -1 is I. We deal with that first. We simplify this. 125, that's 5 times 5 times 5. So I know I can bring a 5 out. I can take 2 into x squared. That gives me an x. I have no x's left inside, but I do still have a square root of 5 left inside. So my answer for this is going to be 5ix times the square root of 5. Now, one thing I need to mention here. When you're dealing with an I in your answer, you're always going to treat it just like a variable. But from now on in your math career, if you see an I, it is okay to assume they're talking about an imaginary number. There are enough variables out there. There are 25 other letters we can use for variables, plus a whole bunch more if you think about the Greek alphabet. So there is no need to ever again use I. We can assume from now on, if you see I in an algebraic equation, that I is meant to be an imaginary number, okay? So don't get confused. They're treated in the math problems as variables, but you need to understand that I represents the square root of a negative number. So it represents an imaginary number. And to say this answer, we would just say it's 5ix times the square root of 5. The order of the variables really doesn't matter. Understand I is still an imaginary number. I will sometimes call it a variable. You could say 5xi square root of 5. That would be fine too. It doesn't really matter. I tend to put the letters in alphabetical order. Okay? Some teachers like you to put the I separate from everything else. That's okay. I always put the letters in front of any square root that I have left. Remember, for your answer to be in simplest form, you cannot ever have a negative underneath a radical sign. So you will have to take that I out in order for it to be in simplified form. For this one, the square root of -18, that's the same thing as the square root of -1 times the square root of 18. Square root of -1 is I. 18 is 2 times 9. 9 is a square number. That would be 3 times the square root of 2. And so if I multiply those together, that's 3I square root of 2. So with that I being in there, that tells me we started with a negative root. Here, when you have two negative roots multiplied together, a common mistake for that is students look at that and they say, oh, well, I can multiply those together, so that's the square root of 150. That's what you would think. But if you have an I in this, and this, again, is going to be the most common mistake, okay? If you have an I in the root number, the very first thing you have to do is you have to take out the I before you do anything else. You have to do that. So, if I take the I out of this one, I have I square root of 10. If I take the I out of that one, I have I square root of 15. okay? Now, I'm going to multiply those two things together. Well, I times I is I squared. Square root of 10 times square root of 15 is square root of 150. Now, with 150, that's the same thing as 6 times 25. Well, 25 is a square number, so I can bring a 5 out. So I'm going to bring out the 5. I have I squared, and then I have a square root of 6 left inside. Now, we need to talk about what I squared means, because if I is the square root of -1, I squared must have a value as well, okay? So let's go over here, I squared. Understand that I squared is the same thing as I times I. So we know from over here, I is the same thing as the square root of -1, okay? If the square root of -1 is multiplied by the square root of -1, we have to treat that the same way as if we had something like the square root of 2 times the square root of 2. What would that be? It would be 2. The square root of 5 times the square root of 5 is 5. The square root of -1 times the square root of -1 is -1. So you need to commit to memory. I squared is -1. So anytime you see I squared in an equation, understand the I is an imaginary number and I squared is -1. So I have an I squared here. I'm going to substitute that for -1. So what I really have is 5 times -1 times the square root of 6. And if I simplify that, I have -5 square root of 6. Understand, if I had forgotten to take out the negative here, and I forgot to bring out the i's, I would get everything right except for the sign of my answer. So it's going to appear that you get a nice answer and everything works, but if you forget to take that negative out first, all of them are going to be wrong. So you need to make sure, if you have a negative underneath the radical, the very first thing you do is take out that I. If you don't, they're all going to be wrong. And think about it, in Delta Math, that's going to give you extra work, right? Because it's going to make you do them until you get them right. So make sure the first thing you do is take out the -1. Now, what happens if we have something like this? -2i times -7i. They're not underneath the radicals. So since they're not underneath radicals, it's okay to multiply those together. So -2i times -7i is 14i squared. And then hopefully you remember I squared is -1. So that would be a -14. So we get some really simple answers with these, but we have to understand how to deal with that negative underneath the radical. In this one, we've got the square root of -12 times the square root of -2. I'm going to take the I out first. So that would be I square root of 12 times I square root of 2. Now I'm going to multiply them together. So I've got I squared times the square root of 24. Then 24, that is 4 times 6. I can bring out a 2. So 2I squared times the square root of 6. And then we know I squared is -1. So that would be a -2 square root of 6. So our i's all drop out when we end up with an I squared, which is nice. Here, I have a -3i times 2i. I'm going to go ahead and multiply those together. That would be a -6i squared. I squared is -1, so -6 times -1 is just 6. With this one, I'm going to simplify everything that I can first. The square root of 16, there's no negative in there, so that's just 4. Minus, I have a negative here, so that's I times the square root of 100. Plus, the square root of 169 is 13. Minus, I have a negative, so I have an I square root of 24. Then I'm going to simplify. I've got 4 minus 10i, because the square root of 100 is 10, plus 13, minus 24, again, is 4 times 6, so I can bring a 2 out. So that's 2i, square root of 6. Then I will add my like terms. 4 plus 13 is 17, minus 10i, minus 2i, square root of 6. It might be tempting to try to add these together, but remember, if you have something with a square root in it, you can only add it to another square root of 6. You can't add that. It would be very tempting to put minus 12i square root of 6, but you can't do that because unless they both have a square root of 6, you have to leave it like this. Now this is hinting to something called a complex number, and we'll talk more about that in just a minute. But complex numbers are when you have an imaginary part and a real part in an answer, and sometimes there's no way to combine those two parts together. So you'll get something that looks a little bit more complicated. Here, if I simplify that, I'm going to bring the negatives out first. So I've got I square root of 32 plus I square root of 8 minus square root of 27 plus square root of 18. So I brought the i's out. For this one, square root of 32, that's 2 times 16. 16 is a square number, so I can bring a 4 out. So that's 4i square root of 2 plus 8 is 2 times 2 times 2, so I can bring a 2 out. That's 2i square root of 2. 27 is 3 times 3 times 3, so that's 3 square root of 3. 18 is a 9 times 2, so that's plus 3 square root of 2. And then we can simplify that. 4i square root of 2 plus 2i square root of 2. We're allowed to add those together because not only are the 4i and the 2i like terms, so are the square root of 2 and square root of 2. Remember, we can only add square roots together if the same number is underneath the square root. So we've got 4i plus 2i is 6i, and then the square root of 2 just comes over as a like term. And then here, there's nothing else we can do with those. So that's minus 3 square root of 3 plus 3 square root of 2. And that's all we can do with that problem. So I have one more problem to do with you, and I'm going to introduce complex numbers with this problem. Our square root of negative 36. First thing I'm going to do is bring out the I. So that's I square root of 36. That's square root of 12. 12 is 2 times 2 times 3. So I can bring a 2 out. So that's 2 square root of 3. And remember, if you need to show more work, you can do that, but I think we should be at the point now where we can do some of this without showing so much work. Here I've got minus I square root of 16, and then minus, that's 3 times 3 times 3, so that'll be 3 square root of 3. And then I'm going to simplify these radicals that are perfect squares. So that would be square root of 36 is 6, so that's 6i. Plus 2 square root of 3 minus 4i minus 3 square root of 3. And you hopefully are getting to the point now where, you know, if you see a square root of negative 36, that's a 6i. And hopefully you can go straight from here to here pretty quickly. It's not necessary to show all the work once you get the hang of it, but at first in the notes, at least, I'm going to show that every time, just so that you don't forget to take that I out. That's extremely important because you'll get every single one wrong if you don't do that first. And then at this point, I'm going to add like terms. So 6i minus 4i is 2i, and 2 square root of 3 minus 3 square root of 3 is negative square root of 3. Okay? This is the first introduction we have to a complex number. A complex number has a real part and an imaginary part, okay? The real part would be the part that doesn't have the I in it, and the imaginary part would be the part that has the I. And a lot of times they will refer to complex numbers as A plus BI. The A is the real part, the BI is the imaginary part.